Well, this is the first scenario with projectile motion where something is being launched horizontally. In other words, it has no um, vertical velocity whatsoever. It's just being launched sideways. And we can have the velocity here, the horizontal velocity set at zero, so that the ball just drops. And let's see what happens here. So I've had this in slow motion, and I have the velocity vectors turned on, so you can see in green. Just watch now. You can see that there's a green arrow, and you can see that the vertical velocity vector is growing the whole time that it's falling, which is what you would expect. The v is increasing as you go down, and we can place this measuring thing here, and we can find out how long it took to fall. So 1.43 seconds. The range, which is the horizontal distance that it went, is obviously zero, and the height at this point is zero. But what we can do now is we can change this and we can give it any kind of initial horizontal velocity. So it's going to be launched sideways. And let's see what happens. So now our initial vertical velocity is still zero, but we have an initial horizontal velocity of 13. And you can see here now that the green vertical velocity vector is growing the whole time that we're in flight, but the horizontal velocity vector was not growing at all. Let me just repeat that and then I'll freeze frame. So you can see here now, there's the 13 meters per second, and here the v is increasing in the downward direction. But if we go forward a little bit, this is still 13 meters per second, but the v has increased in the downward direction. So while this is falling, the v is increasing in the downward direction, but it's not changing in the horizontal direction at all. It maintains the 13 meters per second the whole time. It's just moving sideways at that rate. And then if we let it hit the ground and check the time, well, that's exactly the same as when we let it just drop straight down. And what that tells us is that the time it takes for something to fall is unaffected by the horizontal component of the velocity. The only thing that matters is the initial vertical component of the velocity. And here, it doesn't matter how fast you launch it. Let's do this again. I can go up here and give this, like, let's say 20 meters per second, launch this. It's just going to go further sideways. The time in the air is still 1.43 seconds, but the range has increased, and the range is really easy to calculate. All you have to do is multiply the 13 meters per second by however many seconds it was in the air, and and you know how far it's going to go sideways.